Hey, how we doing? Mr. H here. We are going to be, as I grab my pens and scramble around here, chatting a little bit about evaluation and graphing polynomials today. Kind of what they look like, what we call them, a few of the different things that we look at like those. So, when we are talking about polynomials, the degree, okay, the largest exponent that we see gives us the name, okay? So if something has a degree of 0, it's called a constant term. So you may have something like 4, just a number, okay? There's no variable, so that would be a degree of 0 when you don't see a variable. It's going to be a constant. Excuse me, itchy nose today. Okay, linear is degree 1 because it makes a line. So maybe you have something like y equals 2x, because we know there's an exponent of 1 on here. If I graph that, it makes a line. So that would be linear. Quadratic, excuse me, we've done those this year as well. X squared, we get our parabola. Might open down if it's negative, might open up if it's positive. But we work through some of those things, okay? 3 is cubic, like you cube something. So you're like, okay, Hardy, I kind of get where you're heading here. Okay, now it doesn't mean when I'm just writing x to the third. I could have something here that says y equals 4x to the third minus x squared plus 7. The only thing I'm paying attention to is where's that biggest exponent at, okay? Because that's how I define the type of polynomial that I have, okay? Quintic, I always tell people, think of a quarter or quarters in a dollar, okay? So let's say it was written something like this. Now this could be kind of weird. You're like, well, Hardy, that looks like a quadratic. Don't get sucked into thinking that just because the first exponent you see is here, that's the biggest one. Always look for where the biggest one is. That's going to tell you how to define that polynomial. Quintic is 5. I don't have a good trick on remembering quintic. It's just 5. And anything that is 6 or above is a polynomial. Okay, we just call it polynomial. We don't have special names for those. They must have gotten bored and ran out of ideas to come up with names for them. So when we're doing these, okay, decide whether the function is a polynomial. If it is, write the function in standard form and state its degree, type, and lead coefficient. Okay, so let's get locked in here on what these different things are. Standard form. Largest degree to least. In other words, go looking at the exponents, and when you find the biggest one, write that term first, including its coefficient, okay? And then I look for the next biggest one. That's here, and that's a positive 1/2 x squared, because I don't see a sign. And then the minus 7. So standard form is just biggest exponent to smallest, okay? The degree we just got done talking about up above is that largest value. It's going to be 4, and I get that in there. Okay, type, degree of 4, quarter, quartic. And our lead coefficient, we're going to make one note on this, okay? You have to be, well, okay, you don't have to be in standard form, but you're probably going to want to be, because if you're not in standard form, your lead coefficient is the number at the very front of your problem. If I did that here, I'd say it's 1/2, but that's not right, because the lead coefficient is the value that's in front of your largest degree. So in this case, my lead coefficient would be -3. So putting it in order is probably a really good idea to make sure that we have it that way. Okay, next one I look, okay, standard form, biggest. And the next one. And the next one. Just work your way down. Degree is always the biggest one. Okay, type, fifth is called Quintic. And again, you've got these available when you're working, so it's not going to be a bad thing. And our lead coefficient, not 6, but 2. Okay, so that's just kind of some definition type stuff. So when I'm talking about things, you know actually what I'm talking about, which is important any time you're trying to communicate. Another way we can evaluate, solve, answer a polynomial is to use direct substitution. And it really is as simple as solve this when it's evaluated at x equals 3. Okay, that is just the x value that I'm subbing in, whatever number's in the parentheses. So basically, I'm going to take what I have here, and every time I get to an x, I'm going to use parentheses and try to keep my writing utensils straight as I substitute that 3 in every time I see an x. Now at this point, let's be honest. Y'all going to be using the calculator? Yeah, I probably would be too. So again, you can hammer these out individually. Just keep using parentheses though. That's going to be critical with these, because if I forget my parentheses, that can get to be a bit of a problem. So f of 3 equals 98. And we're good. Okay. So as I evaluate, again, it's just taking, if it doesn't say f of the number, if it just says x equals 1, it just means you plug that in. Now be careful. Those aren't parentheses, those are absolute value bars. 1 minus 2 is -1. And what do we know about absolute value? That whatever answer comes out of there, and I can't simplify -1 anymore, comes out positive. Then I do the multiplying. I don't multiply and then look for it. I've got to work through this. And the other reason I bark about using parentheses, which I was bad about there in number 6, is for a situation specifically like number 7, where here I'm plugging that -2 in to 2 different x places. But that negative comes heavily into play if I forget my parentheses. I would get a different answer. So here, get that typed in. Now, if you wanted to, it wouldn't be a bad thing if you kind of challenged yourself and said, okay, I'm just going to do this piece by piece here. So like here, just to remind yourself with order of operations, I'm only squaring the -2. I don't multiply and then square. That won't work. So -2 squared is 4 times 4 is 16. 2 times -2 is -4 minus 1. I get the same thing. Okay. And if I want to be proper, and I like being proper, I'm going to go ahead and I'm going to label it whatever the function name is, whatever letter, and then whatever number I plugged in for x is what goes in the parentheses. Just to get used to the notation. So when you see it sometime, it's not going to cause a problem. Okay, I'm going to take a quick peek, look at something. Okay, that's what I wanted to see. So now we're going to get into the graphing part of this. So the end behavior of a polynomial function's graph is the behavior of the graph as x approaches positive infinity or negative infinity. Okay, here's what that means in English. So let's say I have a graph, okay? I have an x-axis, I have a y-axis. And I have some graph going on. Let me just kind of make something up here. Okay, so here's what we're asking. As x goes from negative infinity, numbers get more negative as you go to the left, to positive infinity, as I go to the right, what's happening to y? What's happening to f of x? Is it going up to positive infinity, or is it going down to negative infinity? So do I want to use this as my example here? Yes, I actually do. I'm going to use this. Now I'm going to peek and see if I'm doing the exact same thing I have back here. No, I am not. Okay. So here's how this works. I'm going to speak, okay, in what I call English, left, right, up, down, but we're going to write it mathematically. So here's how this works. So as x goes towards negative infinity, okay, as x goes to the left, find the left side of my graph, okay, right here. That's the furthest part left. What direction is my arrow going? Is my arrow going up or down? It's going up towards positive infinity. So basically what we're saying is y goes up as x goes left. As I'm going left, I'm going up. But we don't use up, down, left, right. We use the lingo. Okay, that's why I like having this little picture here and graphing it so I can literally see the arrows going towards that. And then I do it the same thing for this one. As x approaches infinity, okay, infinity on x is to the right. Okay, so as I'm going to the right, here's my arrow. I always find my arrows going to the left and right. My arrow going to the right, is that going up or down? It's going up toward positive infinity. I would find a piece of paper, I would find something, if I didn't want to have my notes out when I was doing end behavior, and I would do this. I'd say, okay, end behavior. If you need to pause me to go find a sticky note or something, do it. Do it, do it, do it. Because if you know these couple of basic things, this is not going to be hard. Okay, end behavior. Positive infinity, negative infinity. Okay? Y. Positive infinity, negative infinity. And this way, when you're looking at graphs, you can kind of finger your way through and go, okay, so am I going up or am I going down? Because the x part never changes. Okay, notice there weren't blanks on the x part. Those aren't going to be any different. So let's try this out. All right, so we're going left and right, and we're going to sketch things. So f of x, fancy name for y. Now, 4x. Most of us know that's linear and what that's going to look like, but if you're not sure, okay, graph it. There it is. I don't have to have a perfect line. I just need a sketch. So now, remember what we said. Okay, here's my end behavior. What's happening? As x is going left, okay, find the left side of your graph, find the left arrow. Is it going up or down? That's the only question we're having to answer. Well, Hardy, it's going down towards negative infinity. Y goes down as x goes left. That's true. Okay, so then I move to the second part. Okay, as x goes to positive infinity, as x goes to the right, find the arrow on the right side of the graph. Is it going up or down? It's going up to positive infinity. Y goes up as x goes right. Up to the right. Bingo! Okay? Keep this handy. We're going to need it again here in a minute. Work my way through all these bells and things. All right. Let's pop this up on the calculator. Again, we should know. We're like, hey, wait a minute. It's a quadratic. Quadratics open up or down. Negative should be down. And that gets shown right there. There it is. You know the questions. Again, as x goes left arrow, what direction is it going? You know it, up or down? Down to negative infinity. Okay. As x goes to positive infinity, as x goes to the right, find the right arrow. What direction is it going? Down. Y goes down as x goes left. Yep. Y goes down as X goes right. Yep. It's just the lingo. That's why we have the card until we get used to it. All right. So now, graphing calculators, we're going to find domain and range. We're going to add one more piece to this. So here we're going to want to be a little more careful with our graph and not just completely sketch. So make sure we hit that right arrow when we're doing exponents to make sure that we get it done right here. Okay. So I'm going to get an idea of my graph by looking at it this way. Ooh, that's kind of funky. Here's what I'm going to do to be a little more accurate. I'm going to do second graph. I want the table. I don't want numbers that big, I'll guarantee that. Anything that will fit in your screen. So -2, 9, and -1, 0, 0, 1, and 1, 6. And then I'll look at the picture again here. So I'm like, all right. Okay, so something like that. So let's actually do our end behavior first, because that's what we're kind of used to here. Handy dandy help sheet. Okay. So here we go again. As X goes left arrow. What way is Y going? Up to positive infinity. Y goes up as X goes left. Yep. Okay. As X goes to positive infinity, as X goes to the right. Right arrow. What way is it going? Up. Okay. Hasn't changed. Now, domain and range. Quick reminders. Domain. X values. Left to right. Okay. As this graph continues to stretch upward here, it's also going out slightly, and this is going out slightly. Out slightly to the left. Out slightly to the right. Now, is that every single domain you're going to run into? Not necessarily, so don't quote me on that. Okay. Range. Y values. Bottom to top. Now, this one's a little more interesting because the top, well, top we're going up forever. So now, range. Let's pull our chart back up here. Does it look, so the smallest Y value I see is 0 at -1. So let's look at the graph again. 0 at -1. It doesn't look like it goes down any lower than that. So we're going to roll with 0, okay? And so for all of these, last one we'll see here, our main thing is just going to be understanding like the end behavior and being able to visually see the domain and range and things like that, because that's going to help us out the most. This will be cool too as we're doing some of these live in class. I'll have them posted ahead of time, but if you're looking at it and you're looking live in class and doing stuff where you can actually go back and forth with me, like, hey, how did you get that, exponent out of being up there and down back into the regular spot? I'm looking forward to it, being able to actually, chat with some of you during the lessons here. So, okay, that doesn't look too terribly difficult. So let's see here. I got 0, -5. I got 1, -4. I got 2, 1. And then everything else is kind of crazy. So I'm going to do one of these. Okay. So let's just take them in order this time. So domain and range. Keep that in sight here. That might help a little bit. Oh, moving me. I want to still see me. So domain, stretching out to the left, stretching out to the right. Still looks to be infinite. It's going to be rare that it wouldn't be infinite, so just as an FYI. Now range, down forever, up forever. You'll start learning with these that if you have even degrees, you're going to see the similar domain and range, and you see odd ones like 3 or 5 or 7. You're also going to see similar things, but that's a little more down the road. Okay, end behavior. All right, one more time for our handy dandy chart here. So again, as x goes to the left, there's my left arrow. What way is it going? Down. Y goes down as x goes left. That's true. And then on the right, as x goes to positive infinity, up, 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 to positive infinity. Now, the work for this, okay, the practice here on the back actually is written as an assignment tomorrow. If you want to just, you're like, oh, I just got the lesson. I need to do this while I'm thinking about it. Jump in, go ahead, do it right away. That way you can ask some questions if you need to, check the keys, things like that. But other than that, I think that's going to do it for today. So we will see you next time.